Hi, welcome to another IGCSE physics video. In this video, we're looking at section 1.10, part 1, which is energy and types of energy. In this video, we will learn about the basic definition of energy. We will learn about the conservation of energy, and finally also the different types of energy that exist in this universe. So what is energy about? Energy is defined as the capacity to do work. It's a measure universally of the amount of work that you have done. In physics, the quantity of energy is measured in joules. Energy is represented by the letter E, while the unit of energy, joules, is written by letter J. So what does the definition of energy, the capacity to do work, mean? Well, in this example, I can see that this person is about to run on a track. Then this person has some energy inside them because they have the capacity to run across this track. And when they finish running across that track, they will have done some amount of work, which is also a measure of energy. In another example, the amount of work done could be pushing this box from this point to this point. So the distance that you've traveled pushing that box all the way from here to here will determine the amount of work that you've done. Now let's talk about the conservation of energy. The law of conservation of energy says that energy cannot be created or destroyed. The energy will always be constant in a grand scenario. Let's say that you were standing at this point with this box and you decided to push it all the way towards here. And this is where you end up finally. We think that in real life we would have more energy over here, but then when we push it, we'd end up with less energy over here. And we think that the energy has been used or it has been destroyed, but that's not the case. In physics, when you push that box, the energy from your system will be transferred to that box so that that box can be in motion from this point to this point. In other words, your internal energy has been converted to the kinetic energy, which pushes that box all the way here. So the terms like used energy or spent energy in order to push that box are not really respectable terms in physics, because energy is not spent or used. It's in fact transferred. And this is the correct term to use when talking about energy, because energy is always constant. The total energy here was equal to the amount of energy that's in your final state after pushing that box. So another clause of conservation of energy is that energy is transferable. So your energy in this initial state, represented by the letter E with the subscript I, would equal to the final energy that you're left with. The only difference here is that your energy, which is the internal energy that you use to push that box, has been converted to kinetic energy that is in the box because it's in motion. Now let's talk about the different types of energy. The first type of energy is potential energy. Potential energy is energy held by an object relative to other objects. So if you have two balloons in which one of them is inflated with air and one of them has no air inside, then this one has more potential energy because it has the potential to burst out all of the air, and then that balloon would transfer all of that potential energy into a different type of energy, like kinetic energy. While this balloon doesn't have much potential energy because it's just going to remain and it won't burst out air like this one. There's another variant of potential energy, which is gravitational potential energy. Gravitational potential energy is the energy possessed by an object that has the potential to fall due to a gravitational field that is nearby. So if you had a book on a shelf and the ground was here, then this book would have a potential of falling if you apply some force or a disturbance like an earthquake. Then that book would fall down, and the potential energy of that book would be converted into a different type of energy, like kinetic energy as it will be in motion, or sound energy when it hits the ground. And so the higher your object is, the more potential it has to fall down, the more energy it will require for it to accelerate downwards towards the ground. So higher objects have more potential energy than objects that are lower in altitude from the ground. Another type of energy is kinetic energy, which is the energy possessed by an object due to motion. So if you have a car that is traveling at a velocity of 30 meters per second in this direction, then it has some kinetic energy as it's in motion and it's traveling on some road. Or you could have some boy who's holding a ball out on a cliff and is about to drop it. Well, here we know that this ball is high, so it has high gravitational potential energy. And as soon as that boy releases that ball, the ball's gravitational potential energy is going to get converted into kinetic energy, as that ball won't be stationary anymore, but it will gain velocity until it reaches this point where it comes to a lower level of gravitational potential energy. But it has more velocity as it accelerates down the cliff, so it has higher kinetic energy. Another type of energy is chemical energy, in which energy is stored in the bonds of substances. So let's say you had a hydrogen atom, which is given by the formula H2, if you remember from chemistry. Well, to have this hydrogen atom bond with this hydrogen atom, we have a bond that is produced here to keep the two atoms together. And there's chemical energy that is present or stored in these bonds. Another example is of H2O, which is also known as water. In this example, this molecule has more chemical energy because it has two chemical bonds. However, the chemical energy required to make a bond is also dependent on the atoms that you're bonding together. Another molecule could be carbon monoxide. In this case, we have three chemical bonds between the carbon atom and the oxygen atom. So this one probably has more chemical energy than a single bonded hydrogen atom. Another type of energy is strain energy, which is energy stored in an elastic body. And an elastic body could be like a rope or some rubber band. So if you stretch a rubber band between two fingers, so if you stretch it like that, then this rubber band would have more strain energy as you're applying more pressure on the ends of the rubber band and stretching the molecules of the rubber band as well. Another example could be a spring. If you load it with some heavy material like a lead block weighing 10 kilograms, then that spring would extend because of that load. And that loaded spring would have more strain energy because the load is putting strain on that spring, while this one has no load on it. Another energy type is internal energy. The internal energy of a body is the combination of its kinetic and potential energy. So you could have a balloon which would be filled with some gas. Argon atoms would be moving around at high velocity, so they would have kinetic energy. And those atoms that aren't moving much will have more potential energy as they don't have much motion and therefore lesser kinetic energy. So you could also say that internal energy is the energy of the motion of molecules in this system. Another type of energy is sound energy, which is stored in sound waves or disturbances in particles of a medium. So as I speak right now from my mouth, I'm creating sound waves which are in the form of compressions and rarefactions in which particles compress and expand. We will talk about sound energy more when we come to block 3, but this is all you need to know about sound energy for now. Another energy type is light energy, which is energy stored in electromagnetic waves. So let's say you had a microwave oven and you had some radiators and you were trying to heat up some noodles. Well, the microwaves from the radiator would hit the water molecules in your noodle, and they would make the water molecules vibrate vigorously and your noodle soup would heat up fast. Another example of light energy could be from the sun. So your sun is emitting visible light towards the earth and you're seeing that light right now as you look out your window. If it's nighttime for you right now, then you can see that light is being reflected from the moon that is coming from the sun. And if you're in daytime, you can use that light on your solar panels to generate electricity. And yet another type of energy is electrical energy, one of the ones we're most familiar with, and we use it every day in our appliances. So as you watch this video right now, energy that is being carried from your electrons are powering your phone or whatever device you're watching this on, your laptop, your desktop, or suck all the dust out of your carpet that you haven't cleaned in years. And finally, nuclear energy is also a type of energy, which is energy that is released in the fusion or fission of atomic nuclei. Fusion is when you bombard a particle into another particle, and that releases a lot of energy. While in fission you have one particle and you hit it with a smaller particle, then that particle will split into two or more particles, which will also release a lot of energy. So this is nuclear fission, which is commonly used in atomic bombs and also to run nuclear power plants, which provide electricity for your home. There's also fusion, which is in suns and stars, in which deuterium atoms, which is a type of hydrogen atom, they collide with each other to form a heavier element, and that also releases a lot of energy. And this is it for section 1.10 part 1. I hope you now understand what energy is and the law of conservation of energy, and also the many types of energy that exist in this universe. Leave a comment in the comment section and provide feedback so I can improve my videos in the future. And I'll see you in the next video. Thanks for watching.